Okay, so today we move into a new set of identities to add to your sheet of formulas that, that you might want to know. This goes a step beyond the Pythagorean and the quotient and the reciprocal, and they're used to help you solve tricky stuff. Now, the whole idea is, why are we doing this? Well, what if I was your teacher and I asked you, hey, I'm going to need you to find the cosine of 15 degrees, and then I said, but hey, don't use a calculator. For some of you that might be a little scary because, well, we don't we don't have this memorized on our unit circle. And so the goal of the sum and difference identities is going to be to use the formulas that are going to be shown to try to figure out a way to create 15 degrees and to solve it. And so an idea would be, okay, well, instead of this, maybe I think of 15 as a combination of two other angles, whether I'm adding or subtracting, whatever comes to mind. And you don't just want to pick two random angles like, oh, okay, well, let me do like, 90 minus 75. Okay, well, if you chose 90 minus 75, okay, you might know the cosine of 90 degrees, but you don't know the cosine of 75, so that's not going to help you. But if you picked two angles, like I'm thinking 45 minus 30, okay, so I just picked two angles that I do know on the unit circle, and those come together and make 15. Now, the reason these identities exist that I'm about to show you is because what most people might think, okay, now this is going to be wrong, so don't write this down. A lot of people see this and go, oh, this is a piece of cake. I can just distribute the cosine of 45, the cosine to 45 and the cosine to 30, and I'll just do my math this way, and I'll just be like, oh, the cosine of 45 is root 2 over 2, and the cosine of 30, remember your unit circle, what would that be, root 3 over 2, and they'd be like, oh, I finished. Okay, no, this does not equal that. And so that is why you're about to see a horrific looking set of formulas. They look really bad. They're not as bad as they are, but I promise this is how, what you're about to see is how you would expand what we just did. So here they are. Now, yowza. Okay, you might want to pause the video right now and copy all of them down, and then I'll chat about ways to remember them. Okay, so if you're watching, it means you've already copied them down. Now, I used X and Y as my variables. If your teacher did an A and a B or a U and a V, same thing, right? You just need to make sure you change it over here on this side. So now let's talk about a couple of memory tricks. The way that I used to memorize these is for cosine, I would remember the rule triple C. So for triple C, meaning I knew I needed to, if I saw a C here, it was C, C, C. So that was my remembering. The first three things that I need to write down are a C, okay? And then when I went to the sine ones, my memory trick for myself was sine, same sign. Okay, so because you may notice in the ones up here, if it's a cosine and there's a plus, you actually have to switch it to the opposite sign in the middle. So if I remembered sine, same sign, then I knew that those were the ones that match, so cosine needed to alternate. I also remembered that if I did triple C here, then on the other one, sine was the one that was all scrambled up, okay? Now, I didn't really have a memory trick for tangent other than I remembered that the sign in the middle is the sign on the top, okay? And then I knew I had to switch that when I went to the bottom. But these are your formulas, and this is what we're going to do to practice really that same problem we just did a second ago when I showed you the wrong way, okay? So let's do cosine of 15 degrees. And if you're a note taker, this would sort of be the, how are we going to use these identities? And so the first example would be cosine of 15. Okay, so we already talked about the fact that you want to start by splitting it into two angles that you know from the unit circle. So I'm just choosing these two. You could also do, I guess, 60 minus 45. I mean, there's a lot of combos that you could choose, but I'm choosing this one. So now that I have this, it's like this angle is your x from above, and it's like this angle is your y from above. And so you want to write out the formula that we had before, cosine x, cosine y, plus, since that's a minus, that's a plus, sine x, sine y. So I'm writing it like this, and then what I'm going to do is come in here where my x's and y's are, and I'm going to replace those with the angle above. So hopefully this isn't too killer. I'm literally just looking above, matching parts, and I had to use my identity that we just copied down. And now is the fun solving part. So here we go. It is unit circle time. Yay! Hopefully you're comfortable enough with your unit circle now that you can start to do these pretty quickly. Okay, cosine of 45 is the x at 45. Okay, so we're replacing that whole thing with that. I'm going to go ahead and put a times here because that's the relationship I see. Cosine of 30 is root 3 over 2. Make sure you recopy your plus. Sine of 45 is root 2 over 2. And then sine of 30 is 1/2. So now that you have these, you just have to remember your radical math. So I'm going to do square root of 2 times the square root of 3 is the square root of 6. And it's over 2 times 2, which is 4. Square root of 2 times 1 over 4. Okay, so this is your answer. Don't try to do too much simplification. Now, they do already have a common denominator, so I'm going to go ahead and write them like this over 4, but there is no legal way to put these together, so please just stop right here, okay? So here's the cosine of 15, and is it a pretty number? No, but if you got a decimal for this, like let's say I typed this in the calculator and got a decimal, it would in fact be the same decimal that I would get if I went to my calculator and typed in the cosine of 15 degrees. Okay, this is the exact answer. That is the decimal approximation if you were to type it in. All right, cool. So how else might you have to use these? Okay, well, another example might be working backwards. Let me switch colors here. Okay, so another example might be that you actually see something like the tan of 40 minus the tangent of 10 over 1 minus tangent 40 tangent 10, okay? And you're told to solve without a calculator. Solve without calculator. That might be your directions. Or simplify might be a better word. There's no equal sign, so simplify is probably better. Simplify without a calculator. Well, without a calculator, you don't know the tangent of 40. You don't know the tangent of 10. But what the hope is that you recognize this layout as being the same as this layout from above. And if you can make that connection that, oh my gosh, wait, that should be a plus. Haha, psych, I was kidding. Okay, that was a plus. Once you notice that that's the same layout as above, then all you have to do is work backwards and go, okay, well, what is this equal to on my identity chart? And if you look back to the left side of the equation, that's supposed to be equal to the tangent of x minus y. So when I plug those numbers in, okay, what is x in this problem? Well, x is 40. What is y in this problem? Well, it's 10. Then it's just the tangent of 40 minus 10, which is the tangent of 30. Now, a lot of times you might stop here because it might be an angle that you don't know. But we know 30 degrees from the unit circle, so we can easily get the answer. Tangent, remember, is the y over the x at 30 degrees, which means you are doing 1/2 over the square root of 3 over 2, which turns into 1 over root 3, or root 3 over 3. This is a good time of year. The students that I work with, I let them know this is a really good time of year to memorize your tangent values, just so you're not always having to do this. This is a pain, right? It's annoying. So instead, if you're up for it, you're already memorizing all kinds of other crap, you may as well just kind of look at this and go, okay, I already know the sines and cosines of these three. What are the tangents of these three? And just so you know, anything that goes with 30 or pi over 6, these are always going to be root 3 over 3. Anything that goes with 45, the tangent's always 1. Anything that goes with 60, the tangent is always root 3. So if you just memorize those 3 numbers, it'll save you a lot of time and effort. All right, cool. So what else? Well, another example might be something like this. Third example. How about, oh, okay, I got it. How about if you're asked to find the sine of A plus B, and it says like, given cosine of A is 3/5 and sine of B is, I don't know, what do I want to do? Maybe I'll do like 5/13. Okay, so this is probably as hard as this kind gets. The idea here is that you first recognize, you know, oh, okay, well, it's a sine of 2 things added together. So you look up above and you actually plug into your formula, right? And then it needs to be sine, same sign, so I need a plus. And then I do cosine of A, sine of B. Okay, so if this is the formula I'm going to use, this is your first step. It's just what's the identity. Then you can start plugging in stuff. Now over here it's given me the cosine of A is cosine of A is 3/5. So right here I can cross that out and I can put in, I want a different color. I can put in the 3/5. Yay! And it gave me the sine of B was 5/13. So I can cross this out and plug in 5/13. But then you're stuck. And if you, I hope you see that. I hope you see that you are stuck there. You can't plug in for these yet because you don't know these. So that's what makes this kind of problem a little tricky, is you have to go and find these by doing old school, like from your last unit, where you have to draw a couple of triangles. I'm going to call this one triangle A and triangle B, where if I put A down in this corner, put B down in that corner. If I put A down in this corner, you have to use what was given about A to set up a right triangle. So this told me that the cosine of A is 3/5, which means the adjacent over the hypotenuse is 3/5. For triangle B, it told me that the sine of triangle B was 5/13, which means the opposite over the hypotenuse is 5/13. And so what that tells me is I probably need to find the third side of my triangle. And I was nice here and I gave you guys easy ones. That's a 3, 4, 5, and that's a 5, 12, 13. And if you didn't know that, just use Pythagorean theorem. Pythagorean theorem, you will get those same sides. And the reason you need this is because now I can go, okay, sine of A, I need to look at the A triangle and do the sine. So the sine, if this is my angle, the sine would be opposite over hypotenuse, so this becomes 4/5. For the cosine of B, I go to the B triangle and I do adjacent over hypotenuse. And now you're ready to roll. You're just going to actually do the math of multiplying these plus multiplying these. So 4 times 12 is 48. 5 times 13 is 65, and then plus, same thing here, 15/65. They already have a common denominator, so I just need to add the numerators, and I get something, I don't know, 63? Did I add that right? 3, I think so. Okay, so 63/65, and that would be your final answer. So like I said, that's as hard as they get. The only other weird ones would be like, you know how we did this one up here, and I actually gave you cosine of 15 degrees. Sometimes you might be given, instead of a degree, you might be given a radian. Like, what if it was like 7π/12, okay? And somebody had asked me to find, ooh, I don't know what that was. If somebody had asked me to do, you know, sine, cosine, or tangent, let's pretend it's cosine again, of 7π/12, you're going to do the same thing you did here, ladies and gentlemen, it's just a little harder to figure these out because you're in radians now. So if it helps your brain, you know, convert it to degrees, then figure out the 2 degrees. If it's okay, then what you could do is just, what I do is the following. I just go, okay, I need a 12 on the bottom, and I know it's going to be plus or minus. I don't know which one. I need a 12 on the bottom. I just immediately go into common denominators and I think, you know, how do I make a 7? So I can make a 7 by doing a 1 plus a 6, but do I know pi over 12? No, I don't. So I don't use 1 and 6. So then I might try like 2 and 5. So 2 pi over 12, 5 pi over 12. Well, I know 2 pi over 12 because what does that reduce to? Pi over 6. So I'm okay there, but do I know 5 pi over 12? No, I don't. So I keep playing that game until I get 2 combinations like 3 and 4, okay? They add up to 7, and when I reduce this, I'm going to know it because 3 pi over 12 is really pi over 4. 4 pi over 12 is really pi over 3. So I start with my denominator, my common denominator, and then I just work on if I reduce it, do I know these from the unit circle? Then I would do the same exact thing that I did there. Okay? So that's kind of how that works. Hopefully that goes well for you, and try a few problems, and then I'll have section 5.5 ready for you later this afternoon. Good luck.